Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Asphaltenes, a byproduct of crude oil production, are a waste material with potential. Rice University scientists are determined to find it by converting the carbon-rich resource into useful graphene. Mohammad Rahman, an assistant research professor of materials science and nanoengineering, is employing RIA's unique flash Joule heating process to convert asphaltenes instantly into turbostratic, loosely aligned, graphene and mix it into composites for thermal, anti-corrosion and 3D printing applications. The process makes good use of material otherwise burned for reuse as fuel or discarded into tailing ponds and landfills. Using at least some of the world's reserve of more than 1 trillion barrels of asphaltene as a feedstock for graphene would be good for the environment as well. Asphaltene is a big headache for the oil industry, and I think there will be a lot of interest in this, said Rahman, who characterized the process as both a scalable and sustainable way to reduce carbon emissions from burning asphaltene. Rahman is a lead corresponding author of the paper in Science Advances co-led by Rice chemist James Tour, whose lab developed flash Joule heating, materials scientist Palikal Ajayan and MD Gholam Kabria, an assistant professor of chemical and petroleum engineering at the University of Calgary, Canada. Asphaltenes are 70% to 80% carbon already. The Rice lab combines it with about 20% of carbon black to add conductivity and flashes it with a jolt of electricity, turning it into graphene in less than a second. Other elements in the feedstock, including hydrogen, nitrogen, oxygen and sulfur, are vented away as gases. We try to keep the carbon black content as low as possible because we want to maximize the utilization of asphaltene, Rahman said. The government has been putting pressure on the petroleum industries to take care of this, said Rice graduate student and co-lead author Masr. Saadi. There are billions of barrels of asphaltene available, so we began working on this project primarily to see if we could make carbon fiber. That led us to think maybe we should try making graphene with flash Joule heating. Assured that Tour's process worked as well on asphaltene as it did on various other feedstocks, including plastic, electronic waste, tires, coal fly ash and even car parts, the researchers set about making things Y. Saadi, who works with Rahman and Ajayan, mixed the graphene into composites, and then into polymer inks bound for 3D printers. We've optimized the ink rheology to show that it is printable, he said, noting the inks have no more than 10% of graphene mixed in. Mechanical testing of printed objects is forthcoming, he said. Rice graduate student Paul Advincula, a member of the Tour lab, is co-lead author of the paper. Co-authors are Rice graduate students MD Shahjejul Hoke Thacker, Ali Kader, Jacob Beckham and Minj Liu, undergraduate Aasha Zinki and postdoctoral researcher Samyabrata Roy, research fellow Shabab Saad, alumnus Ali Shayesta Zarati, graduate student Shariful Kabria Nabil and postdoctoral associate. The research was funded by the Alberta Innovates for Carbon Fiber Grand Challenge programs, the Air Force Office of Scientific Research, FA 9550-19-1-0296, the U.S. Army Corps of Engineers, W912HZ the 21st of February 50, and the National Science Foundation, 1,849,206, 1,920,954. Make a difference. Sponsored Opportunity Story Source. Materials provided by Rice University. Original written by Mike Williams. Note: content may be edited for style and length. Journal reference. MASR. Sadi, Paul A. Advincula. MD Shahjejul Hoque Thakur. Ali Zian Kader. Shabab Saad. Ali Shayesta Zarati. Shariful Kabriya Nabil. Aasha Zinki. Samyabrata Roy. Minj Lu. Sravani N. Bimaseti. MD Abdullah Al-Bari. Yuen Jung. Jacob L. Beckham. Venkatamana Gautam Shetty. Anirudh Vashist, MD Gola. Sustainable valorization of asphaltenes via flash Joule heating. Science Advances. 2022. 846. doi. 10. 1126. Sci Adv. Ad 3555. Cite this page. Rice University. Asphaltene changed into graphene for composites. Flashed, byproduct of crude oil could bolster materials, polymer inks. Science Daily. Science Daily. The 18th of November 2022. ift.tt/9bpdlrj. Rice University. 2022, November 18. Asphaltene changed into graphene for composites. Flashed, byproduct of crude oil could bolster materials, polymer inks. Science Daily. Retrieved November 18, 2022 from ift.tt/9bpdlrj. Rice University. Asphaltene changed into graphene for composites. Flashed, byproduct of crude oil could bolster materials, polymer inks. Science Daily. https://ift.tt/9bpdlrj. Accessed November 18, 2022. Thanks for watching. Please subscribe my channel for more videos.